what we mean by isomerism. Okay, so isomers. Iso means iso means equal, and mer means parts. So isomer, the definition of isomer is basically the compounds having same molecular formula, but different structural formula, And this is basically the definition that we have studied in O-levels formula. So let me give you some example. Like if you can see that this is basically C2H4O2. So this is basically, we know that a molecular formula, but if we are going to represent its structure, then there are basically different ways to represent the structure. Like for example, we have this structure CH3 C double bond O dash OH. Do you know what is this basically?
Displayed formula.
Yes, it's a displayed formula, but what actually this molecule represents? Which acid? This basically is an acid.
Oh, is it carboxylic acid?
Yes, it's carboxylic acid, and we call this acid as ethanoic acid. Okay.
Okay.
Now, yes, what does this basically represents?
This is this an ketone?
No, ketone has carbon on this side as well. So this is not a ketone. What do you think this?
Is an aldehyde.
Yes, this is an aldehyde. So you can see, although they would be having same molecular formula, but the representation in terms of structure is actually different.
Okay.
Yes. Now we have this structure as well. It can also be represented in this way. Yes. So what does they basically represents? Um, this was basically,
This is also an aldehyde.
no, this is not an aldehyde. This is something like C double bond O dash O. So it basically represents an ester. This is a functional group for an ester. Is that clear?
Okay.
Yeah, because
I
that
don't
was,
think we covered this in the previous
yes, we
lesson.
have not done this yet. We will do it later. This is what you have done in O levels. So that is why I was just like to explain you the structure, that this is basically an aster. Okay.
Okay.
Yes, this is basically an aster. So this is basically a keto. So they all are basically isomers, isomers, because they have different structure representation, but although their molecular formula is same, their molecular formula is same. Okay,
Okay.
so let's move further towards uh, the structures and some more types of isomerism. Now, okay, so now there are basically two type of isomers that we are going to study in our AS chemistry course. The one is basically structural isomer, and the other one is basically stereoisomer. Stereoisomer. Structure isomer, the basically definition is that they would be having same molecular formula but different structural formula. And now they are going to have they are going to have further types as well. And what are those types? The one is chain isomer and the other one is positional isomer, and the third one is basically that is functional group isomer. Is that clear?
Yes.
Okay. And for stereoisomer, I just want to explain you that there are basically two types of isomers, and that is the one is uh, geometrical isomer. The one is geometrical isomer, and we call this type of isomer as cis-trans isomer. And there is also another type of isomer, and that is optical isomer. So there are basically two types of stereo isomers. Now let's move further and let's first discuss about structural isomer and their
Is
type.
the optical isomer the EZ?
Is what?
EZ isomerism.
Yes, yes, yes.
Okay.
And let's discuss the first type, and that is basically chain isomer. That is chain isomer. Let's write the definition for that. The carbon chains are arranged differently throughout the structure. Throughout the structure. Like there is basically different arrangement of carbon in the you can say chains. Let's see about their structure as well. Like for example, we have this structure and that is basically butane. Okay. And we can also write it as like there are, four carbons. We can construct only three carbons as well. And we can put methyl group over here as well. Okay. Over here as well.
But now it's not butane anymore.
Yeah. Now it's not butane. First of all, let's write it is basically butane. And what it becomes now?
Now it's methyl propane
2-methyl
to methyl propane.
propane. You can see that basically the arrangement of carbon atoms in the chain is different now. Here they were having four carbon atoms in the chain, but now one carbon is becomes the branched. Okay, this methyl group becomes the branched. Okay, so the number of carbon atoms on the main chain are three, and on the branch there is one carbon atom. Okay, so although they would be having different molecular formula, but you can see that their structure is basically different. Okay, so this is basically an example of chain isomer. Let's take one more example. This is first example, and let's take another example. So this is carbon. Three carbons are there. Okay, so that would become C3H7, and there is C double bond O dash H is there. Okay, so now it can also be written as, so first of all, let's name this structure. What is this one?
And which one?
This one, this one.
It's one one buta no sorry butan one own.
Yes, you can also write it as butanol. Butanol. That is also fine. So what this
Do you not
becomes?
have to put in a position number?
Yeah. There is no need in this kind of thing.
Okay.
So what about this one? What we call this one as?
This is 2-methyl propanol.
2-methyl propanol. So that is fine. So we can see that the structure of carbon atoms on the chain, the arrangement of carbon atoms on the chain is different. Okay. So this is basically called as chain isomerism. Let's take some more examples. So if we have CH3, CH2, 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 and then we have CH3. So that is basically called to be as,
This is pentane.
yes, so this one is called to be as,
Um, 2-methyl but butan.
2-methyl butane. So again, there is a different arrangement of carbon atom on the chain. Okay, so we will call this one as they are basically isomer of each other. They can also be written as in this form. Yes. Now count their number of atoms. Are they equal? Like they have one, two, three, four, five. They have five carbons, so they also have five carbon. How many hydrogen they would be having? They would be having 12. So 3, 5, 7, 9, 12. So that they are also having you can say 12 hydrogen atoms. So they all are basically isomer of each other. Okay, so what we call this one as, how can we name it?
Chain isomer.
Yes, how we will be
Uh,
able to name it?
this is 2-dimethyl propane.
2,2-dimethyl propane. So they all are basically the example of chain isomer. Okay, so they all are example of chain isomer. So in chain isomer, basically the arrangement of carbon atoms on the chain is different. Okay. Now, let's move further towards position isomer. This is basically its second type. Okay. The functional group is attached to the main chain in different location. So the functional group is attached to main chain in different position. Like for example, now we are going to have, yes, Pity, how we are going to name it?
Um, 1-bromopropane.
1-bromopropane. Now we are going to have hydrogen here, hydrogen here, hydrogen here, hydrogen here, hydrogen here, and hydrogen here, and hydrogen here. So how we are going to name this one?
2-bromopropane.
2-bromopropane. Now you are going to see one thing, that the position of functional group is different in these isomers. This was basically present at carbon 1. We are going to count it from here because functional group is near from left hand side, and we can count it from anywhere. So it's 1, it's 2. So it's basically 2-bromopropane. And here the bromine is basically attached to carbon 2. Okay. So this is
Okay.
basically an example of position isomer. So let's take another example, which is now the functional group is basically OH. Okay, how we are going to name this one?
This is 1 no, butanol.
Butane 1 ol. Okay, and now the arrangement of position of OH group would be changed. It would come here, remaining would remain same. And how we are going to name it? Yes, beta. How we are going to name it?
Butane 2.
Butane 2-ol. So again, we have seen this thing that position of functional group is different, different. Okay. And now we are moving towards another type, which is functional group isomer. Functional group isomer. This is basically the third type of structural isomer. Okay, so let's see. So in this functional isomer, what happens? The reorganized, atoms are reorganized to give a different functional group. Different functional group. And let's see how the atoms are organized. Like for example, CH, this is H, this is double bond carbon, H, this is C, H. Let's first of all write its molecular formula. And we know about the functional group that here functional group is double bond. Okay. So now what I'm going to do, this is basically C4, 1, 2, 3, 4, 5, 6, 7, 8, H8. We can also put it in the form of cycloform. Okay, this is cycloform. And that could be written as this would become cyclobutane. This would become cyclobutane. Okay, just Sultan, just 1 minute, please.
Okay.
So, we have done this example that these are basically the example of functional group isomers because you have seen the functional group was at this point and now here it can be turned into this cyclobutane form. Okay, and now we can see that there is basically no functional group over here. Let's do one more example, then you will be able to know it more clearly. Like, for example, we have this one. What do you think this thing is called to be as? What is this one?
This is um pro propanone.
Propanol.
Propanal.
Yes. So you mean that this is a aldehyde. Am I right?
Yes.
But now, this is basically the functional group. And if I would move this functional group in this manner, that I am going to move this functional group at this place. So let's see what is going to happen. This would become C double bond O and there is CH H over here. You can see that molecular formula is same, but now what it has become? Yes, now what it has become?
Now it's propanone.
Yes, now it has become ketone. Okay, so it has become propanol. So in this way, we are able to, like if we will be able to move this functional group, then you can see that it would be changed from aldehyde to a ketone. Okay. So let's move further. Is it clear, Sultan?
Yes, sir.
Now let's move further and let's see about some more examples of functional group. So this is basically alcohol. This is basically an alcohol, and we know it is basically propanol. Okay. Now I'm going to move this oxygen from here to this place, and let's see what is going to happen. So it would become like this. So it has become, there is carbon oxygen single bond. So it has become ether. Although that is not the part of your course, but you know, must know it that it has become ether. So alcohol has been transformed to an ether. Okay.
Okay.
Yes. So let's see some more examples and kindly join the class after this 1 minute. Okay. After 7 minutes,
Okay.
I'm going to send you the link. Okay. So now we are having this acid, which is carboxylic acid. So if we are going to write it as CH double bond O dash CH and H. So first of all, what was this one? Yes, sir.
Um, is it ethanol?
No, look at this one. This group is basically
Or is it um, is
carboxylic acid.
ethanoic acid? Ethanoic
Yes,
acid.
yes, that is ethanoic acid. And if this carbon double bond O and this O is moved at this point, so it had become, now what is this one to be called as?
This is.
I have just told you before, C
Is
double
it an
bond O.
ester?
Yes, this has become an ester. And how we do name it as? Like first we are going to look at this group. First we are going to look at this group. So this is methyl. Okay. And then this is methanoate. Methanoate. Okay. So we can see that the both are basically a functional group isomer of each other. Now let's take another example, which is C3H6O. So it can be represented as CH3 C double bond O dash CH3. So what do you think this is?
Is this um?
There is carbon on both ends. Just remember that carbon on both ends. And there
Is
is
it a
carbohyl.
ketone?
Yes, this is ketone. And now it has become, yes, now it has become,
An aldehyde?
yes, this was a ketone and it has become aldehyde. With the movement of functional group, you can see that they both have the same molecular formula, but due to the movement of functional group, this ketone has become an aldehyde, and they both are functional group isomer of each other. Now, let's take the last example, which is, yes. So this one is basically, yes, carboxylic acid. And this one is
And this is an ester.
ester. And we call this one as, like, first we will name this one, that is methyl and
Methanoate.
ethanoate. Very good. So you can see that they both are basically functional group isomer of each other. And just due to the movement of this functional group, it has transformed from carboxylic acid to methyl ethanoate, which is an ester. Okay.
Okay.
Now let's move further towards uh, stereoisomers. Let's discuss about stereoisomerism. Okay. So the first type of this that we are going to discuss now is basically geometrical isomerism. And geometrical isomerism is basically also called as cis-trans isomers. So which type of compound can show cis-trans isomer? There are basically two conditions for that. Compound must contain carbon-carbon double bond. So the compound must contain carbon-carbon double bond. And the second thing is that double bonded carbon must have different groups. So double bonded carbon atoms must have different groups attached to it. So these are basically two important conditions that you have to memorize. Okay. So now,
Okay.
uh, this one also. Oh, sorry. Okay. So now, there's an example which is carbon-carbon double bond. Here we have H, here we have Cl, and here we have H, and here we have Cl. So you can see first condition is fulfilled, that it has carbon-carbon double bond. And second condition is also fulfilled, that it has different atoms which are attached to carbon. You can see it is H and it is Cl. Remember one thing, when they have same atom on this side, this is basically called as cis isomer. And when they are going to have different atoms, like this is H, this is Cl, and here is Cl, here is H, then it would become a trans isomer. Is that clear, Sultan?
Yes.
Okay. So let me just give you some questions like This
But
is,
just one question. You know when
yes.
you said the double bond C atoms must have different groups attached, what
Mhm.
does that mean?
That means these groups, they should be different. If it would be same, like the example I am giving you, CH double bond CH2, then it is like this. C has H here, this C has H here, and this C has CH3 here as well. And there is double bond, carbon. Here we have hydrogen, here we have hydrogen. So do you think this is a cis-trans isomer?
No.
Yes, the answer is no, because it has same atoms on this side. These are same. So that is why we will be saying that it is not a cis-trans isomer. Okay. So now
Okay.
let's take another example, which is CH3, CH, double bond, CH and CH3. So it would be like CH, CH3, double bond, CH and CH3. So do you think this is an isomer?
Yes, this is cis.
Yes, it is a cis isomer. Okay. And when it would be like this, like H is here, then H is here, CH3 is here, and CH3 is here. So now it is basically called as a,
Trans.
yes, that is a trans isomer. Okay, let's take some more example related to it. This as well. Like for example, we are going to have, yes, this one is CH3, C, Cl, C, Cl, CH3. Now we are going to write about this one. And this would be like C, this CH3 is here, Cl is here, this Cl, and then we have double bond, again C, we have Cl here, we have CH3 here. So what kind of an isomer this would be?
This is a trans.
Yes, that is a trans isomer. And remember one thing, this trans isomer is basically non-polar. That is non-polar. While a cis isomer, if I'm going to draw a cis isomer, that would be CH3, here CH3, then here Cl and here Cl, that would be a cis isomer. Okay, and that is basically polar because at
Are
his,
all cis isomers polar?
yes, all cis isomers are polar. Then move further and no, only those cis isomers are polar which have these are, they are same. These groups are same and these groups are same. Only these kind of cis isomers, they would be polar. Now let's take another example.
Wait, I'm
Mhm.
confused on what you
Yes,
just
yes,
said.
yes. I'm saying like cis isomer are those cis isomer are polar which have the same groups attached here. Like you can see this same group, the same group, okay? And this is a same group and this is a same group, okay? So only
Okay.
these kind of cis isomers, they are polar. And now move further. Is it clear, Sultan?
Yes.
Okay. So now we have CH3, CH2, then we have CH, double bond, CH, CH3. Now, we know it has a double bond here, and one is H here, and the other one is ethyl group here. We have H here, and we have CH3 here. So this is basically a cis isomer, and that doesn't seem to be a polar one. And here we have this kind of isomer, that is H here, C2H5 is here, and then we have CH3 here and H here. So this is basically a trans isomer. Okay.
Okay. Wait, so even if the CH3 and C2H5 they are different,
Hmm.
how is it still trans?
Mm, no, it can be like this. Like, for example, they should be have like different atoms, different group should be placed here. So you can see this group is different than this one. This should be the major condition. It can be on this side. Yeah, like this is different. I know they both are different. It is a basically a geometrical isomer. Okay. So it must need to be have like different groups. Okay. On either side there should be the different group. Is that clear?
Okay, but do at least one of them need to be the same?
uh like
Like for
no,
example,
no.
the
Yeah,
HH.
yes, yeah, yeah, this.
So this has to be the same.
Yes. Okay,
Okay.
so now let's move further and let's discuss some more examples. Which compound, this is a past paper question, which compound exhibits cis-trans isomer? A is CH3, CH, Cl, CH3. Okay. And let's draw their structures as well. Like this is to be drawn as CH3. Uh, this is Cl here, and this is H here, and this is CH3. Do you think this is a cis-trans isomer?
This is no.
Because there is no double bond. Simple is that.
Yeah.
Let's move towards point part B, and that is CH3, CH, Cl, CH2, and then we have Cl. So first of all, let's draw their structure. That is CH3H, and then we have Cl, then CH, H, and Cl. Do you think this is a cis-trans isomer?
No, no double bond.
Key part we are having, that is CH3, CCl2, and then CH3. So C is CH3 is here, Cl is here, Cl is here, CH3 is here. So do you think this is a cis-trans isomer?
No, no double bond.
Okay, let's take the example of D part, and that is basically CH2, then we have Cl, then we have CH2, then we have CH2, and then we have Cl. So let's discuss about them. This is H, H, and this is Cl. This is CH, H, and that is CH, H, and this is Cl. So do you think this is a cis-trans isomer?
This is no.
Okay, so let's move further towards Cl2. So this is C double bond C now. We are having H here, and we are having, you can say Cl here, and here H, here Cl. So do you think this is a cis-trans isomer?
This is cis.
Yes, this is cis and can be changed to a trans isomer as well, which would be C, and that would be Cl. This is Cl, this is H, and this is H. So this would be a trans isomer. Okay. So this example shows us that a cis-trans isomer must need to be have a double bond with them, and it must need to be like having the different groups on either side. Okay.
Okay.
Yes, Sultan. So this is whole about today's lecture, and tomorrow we are going to start with the last type, which is optical isomer. Is that clear?
Okay. Yes, sir.
Mhm.